We call it the mole. It's named after Amadeo Avogadro, so we refer to it as Avogadro's number. So if I put the numbers up here, the dozen is 12, the mole 6.02 times 10 to the 23rd. So if you were to write that in your notebooks, it would be 6.02 followed by 21 zeros. We don't bother to try to pronounce it in terms of millions or billions. We just write the number in scientific notation. If I want to count something, for example, I have my jar of pennies here, and you guys have used these already. There's a couple ways I could figure out how many pennies are in here, and some of my students have figured out how to do that. A couple different techniques that you can use. I want you to think about how you would count the pennies. I'm going to give you one example. Physically count them one by one, but think of maybe a couple other ways that you could count that. And if you could put that idea that you have, put it right in your notes, kind of like an answer to my question. Other ways that you could count the particles in something. I'm going to turn up the video to get you ready for the next demonstration. Okay, I've rearranged where my computer is located, and I want to show you a little demonstration on the benchtop here. I'm going to try to get this a little closer at points where you can see better. I have lined up 4 rectangular blocks of metal, and they vary in their height. The reason for that is they're comparing something about their sameness. How are they alike? And what I'm going to do is take each block individually, put it on the balance that I have here, and see what its mass is like. So here's the first block, and it's reading 27.1 grams. Let me bring up the computer a little bit so you can see that. 27.01 grams. That's a piece of aluminum. It's a fairly light metal. You guys have experienced that before. Next, I'm going to take a piece of steel. I'm going to place, it's actually iron. I'm going to place that on the pan. That one reads a little higher. It's 55.86. Now, the two numbers that I've mentioned to you, if I compare the mass to the value of the periodic table's mass, they turn out to be very close to one another, given the uncertainties that are connected with the balance. So for the iron right now, I'm reading 55.86, and on the periodic table, I read 55.847. Very good agreement. Next metal is zinc. Gray, a little bit heavy. I put that on. The value on the scale is saying 65.48. I look for element 30 on the periodic table. It says 65.38. We're off by 1/10 of a gram, but not too bad in terms of the ability of the balance to be certain. The last metal, copper, and that's reading 63.58. I look at element 29 in the periodic table, 63.546, very good agreement. So all of these little pieces of metal have different mass, but there's a commonality with all of them. How are they all alike? Well, it turns out that they all have this number of particles in them, the Avogadro number. They all are 1 mole. And you can see that not only are their weights different, but their volumes are a little bit different. That gives us a little concept that we can talk about in reference to the mole. And I'm going to turn the video off so I can put some information on the board and show you that. So I'm realigned again now with a couple ideas that I want to show you on the board here. If I'm counting a dozen donuts, there's some other things that I can measure in reference to the donuts. Let me give you some examples. I can figure out how heavy they are. I can get their mass. Do they take up a certain amount of space? Yes. So I can put down their volume. Are there a number of particles with them? Yes. I can count the number of particles or number of donuts. Do they have energy? Well, we're very aware that donuts have a lot of calories in them, so you can even figure out from the count how much energy might be stored in the donuts. 4 different kinds of measurements, all from counting a dozen donuts. Now, let me do another little comparison here. I'm going to turn the video off for a second. So here's my board now, slightly relabeled. I still got mass, I still have volume, number of donuts. I'm going to change that to number of atoms or molecules, and I still have energy. Up at the top, I'm now considering the mole to be a mole of elements and a mole of compounds. So down here I'm going to put atoms or molecules. Let me fix that for you. So a mole can count things just like the dozen can count things. Let me turn off our video, show you some more. Our final idea that I want to show you deals with a compound, and it's a very common substance that you're aware of. It is water. And what I want to do is I want to show you how we can figure out how much a quantity of a mole of water would be. And there's a very easy way to do that. We were talking about using the periodic table. Well, all I have to do is put down my formula, H2O, and then figure out how much of each atom I have, how many atoms I have, and how heavy they are. So in H2O, I would have 2 times H, and I would have 1 times O. The 1 is understood but not written. I now go to the periodic table, so I grab my periodic table. Element 1 is hydrogen, and element number 8 is oxygen. I look at their masses. I'll put those down. 2 times 1.00, I'll call it 8 grams. And then oxygen, 1 times 15.999. I'll multiply these through. Let me turn this a little bit. This will be 2.016 grams, and this will still be 15.99 grams. And then I'll add them together. The total will give me 18.015 grams. That's what a mole of water would weigh. Now, what's it going to look like? Well, one of the ways I can do that is to actually measure it by mass and compare it to how much space it's going to take up. So let me bring this a little closer to the balance here. So now I have our graduated cylinder. It's dry, it's empty. I'm going to put it on the balance. I'm going to tilt this a little bit so you can see the balance numbers. And without anything on, the balance is reading 0. Let me place the graduated cylinder on top. That's the weight of the empty cylinder. Let me tear that so the balance takes away the mass of the cylinder. And now let me add approximately 18.015 grams of water. So I'm going to add some distilled water here. I'm using a squeeze bottle to do it. And you can see the mass is gradually increasing. We're at 15.41. I'm going to keep going till we hit about 18. 16.75. 17.52, so just a little bit more, and then we'll have our mole of water. Okay, we got 18.21. I've gone over just a tiny bit, but it's still a pretty good measurement. And if I look at the volume on the graduated cylinder, it's about 18 milliliters. So 18 grams of water also matches the volume of 18 milliliters. And the reason for that, something that you studied earlier on, was the fact that the density of water is 1 gram per 1 milliliter. So if I can measure it by volume or mass, I'll figure out what a mole of water was. Could you drink a mole of water? Something I think we talked about before? Definitely. In fact, you drink many moles of liquids, many moles of water through the course of a day. I'm going to give you 2 more examples of compounds. If I want to figure out the molecular weight or the mass of a mole of calcium chloride, Ca and Cl2, what I'll do is count how many atoms I have in the formula. I have 1 calcium. I have 2 chlorines. So I'll use my periodic table. I'll look up the masses of these. For calcium, it's 40.08. That carries through to 40.08 over here, grams. For chlorine, and I have to multiply it by 2, and chlorine is 35.453. What I'll do is I'll multiply that by 2, so I will get 6. And 9, 7. Hopefully my math is okay. And then what I want to do is I add these together. Oops, we're off a little bit. Our mass for a mole of calcium chloride should be about 110 grams per mole. The last compound I want to show you is called magnesium hydroxide, MgOH taken twice. And I'm going to use the same technique, but there's just a tiny bit of a change in how I do this. If I look at my formula, I can see that there's 1 magnesium, so I'll have 1 times Mg. When I look at the parentheses here, I can see that there's 2 outside the parentheses, so that means inside I have oxygen doubled, so 2 times oxygen. And then we also have hydrogen inside the parentheses, so I have to multiply that by 2. Multiply those, and I'm going to look up on my table, my periodic table, the masses. Magnesium, 24.305. Carry that through. I got oxygen, 2 times 15.999 grams. That'll become 31.998 grams. I have 2 times hydrogen, 2 times 1.008 grams, 2.016 grams. The final step is to add them all together, and that will give me the total mass of magnesium hydroxide. Magnesium hydroxide, incidentally, is a compound that you can find in the drugstore in a product which is called milk of magnesia. It's used for some people to neutralize some of the acid that might be in their stomach. The first compound I did was calcium chloride. That actually is a ice melting substance. A lot of times we use rock salt, but calcium chloride, the CaCl2, that's an even more effective de-icing agent. A little more expensive, but it works very, very well with ice. So that's our short lesson for today, and hopefully I'll be able to show you some more examples of things through the course of our next couple of classes.